Hi and welcome to Do More with C++. I'm David Millington, the C++ Builder PM here at Embarcadero. So we're going to cover two things today. The first one very quickly, and the bulk of the talk today will be on the second. But the first is how to add C++ to a Delphi app. And this is particularly useful because if you want to do more with C++, you can take that a couple of ways. You might want to do more with C++ if you're a C++ developer, but if you're a Delphi developer, then you might want to do more by making use of C++. We're just going to go through that very quickly. Then that sets things up so that if you're a Delphi or a C++ developer, it doesn't really matter, how to take any of the C++ code that's out there, and C++ has a vast number of really useful third-party libraries, how to take any of that and how to use it in C++ Builder to add to your application. And that, of course, can be, if you are a C++ Builder developer and you have a C++ app, how to take that and add it to your app. Also, because of number one, that means that we now open the entire C++ third-party ecosystem to Delphi developers as well. So let's very quickly have a look at the first, about how to add C++ to a Delphi application. And we've looked at this before, and at the end of this talk I'm going to give a link to a GitHub repository that contains example source code, so you can see exactly how to do all these techniques. I'm just going to run through an example set of projects. This is a source that you can download from GitHub and experiment with yourself. I'm just going to run through the techniques very quickly. So first of all, C++ Builder can call Delphi code very easily. So I have a C++ project here, and this is a simple form, and it has C++ code. And all I have done is simply add Delphi code right to the project. Just add it as a normal file to the project. When you build, that automatically creates a header file that is a translation of the Delphi code, and you can include that in your C++ application. It's all very straightforward. More interesting, I think, and what I want to focus on here is how you can have a Delphi application and you want to call C++ code. And this is the key that allows you to have a Delphi app, and if you want to make use of all the C++ code out there using the techniques I'm going to show you in a few minutes, this is how to add C++. Here we have a Delphi form with some code. The technique is fairly easy. We simply define an abstract class in Delphi, and this defines the interface that Delphi is going to talk to. We're actually going to create a descendant of this class in C++, but Delphi won't be aware that it's talking to a descendant. Because it's using all the virtual methods, it's just going to have a class instance and it's going to call a method, and it will happen to call the descendant implementation. So we're actually going to create the descendant class in a separate project, a package, and we have a function here implemented in that package, and that just creates an instance of a descendant of this class. And so then in the Delphi code here, we're just going to call that method createCpp descendant, which is in our C++ project. Here is the C++ package. And we have a C++ class that includes the header from the abstract class. So we have just added that Pascal file to our project. It automatically creates the header, and we can then descend from the Delphi class. And we can implement that completely in C++. And we do lots of C++ stuff, such as having a vector. So this is a really ultra quick summary. And if you're interested in doing this, there will be a link at the end to this source so that you can examine it, and also a blog post and hopefully a video that will go into this in far more detail to actually explain what's going on. So one of the benefits of C++ is the vast number of third-party libraries that are out there. And if you're a Delphi user and you're adding C++ to your application, you're probably doing that in order to take advantage of some of these other libraries. And of course, if you're using C++ Builder already, then you probably want to be able to add that code to your app. But how many of those third-party libraries can you actually use with C++ Builder? Because it's very common for many of them to be set up as Visual C++ only, or to use other build systems, CMake, for example. So what I'm going to do is I'm going to pick a common third-party library, and I'm going to show you from beginning to end how to use it in C++ Builder, and I will go through and demonstrate that live, explain what I'm thinking at each particular point, and so forth. It's actually not very difficult. So I was looking for a good library to demonstrate this, and I want a library that is small enough that I can actually demonstrate it in a few minutes, but actually represents the kind of problems that you might run into. For example, something that is built assuming that only Visual Studio exists, and built assuming that you're using CMake or something else. So there's a great Stack Overflow question here: what modern C++ library should be in my toolbox? It is closed, like many useful Stack Overflow questions, but the answers that are present list a great number of very useful libraries. So this answer here, which is a vast list, has quite a few very large libraries. I'm certainly not going to demonstrate adding Juice, for example, today. But to pick a smaller one, there's murmurhash 3 here, which is a very commonly used hashing library. And if you click the link, then we get a GitHub page, and you can clone or download it, which is exactly what I've done. I have a copy here, and I have that as source here as well. So we're going to use this as the basis for converting this project into something that C++ Builder can understand. So first of all, when you look at the source, you can see there's a README, which we already saw on GitHub, and there is cmakelist.txt. So that tells us that this is a CMake project. CMake is not yet supported in C++ Builder, so this is a problem. So let's open cmakelist.txt and see what it tells us. So there are a couple of things here. There's a project, smhasher, and it consists of a library which contains a large number of C++ files, and an executable which has just one C++ files. And these are linked together. So smhasher and smhasher support, the exe and the library are linked together into one executable. So we can mimic this very well in C++ Builder by doing, it's not even really mimicking, by doing exactly the same thing. We want to have one executable which contains just main.cpp, and we want to have a static library which contains all the other C++ files and which is linked into the executable. So let's go ahead and create that. So I want to create a new project, and I'm going to create a console application for the executable itself. And it is C++. I have no target framework because I don't need to pull in the VCL or FireMonkey just for a console app. And you can specify the project source. So because the executable uses main.cpp already, I'm going to specify that here, that I'm going to create this console application. Instead of just being a blank one that we fill in ourselves, it's going to reuse main.cpp as its source. So let's create that, and we can just rename that to smhasher. And we also want the library, so let's add another new project. This time choose static library. Click OK. We're going to rename that to smhasher support, and we're going to add all the other C++ files. So you can see a vast number of C++ files here. I'll select all of those except main.cpp, which has been added to the main executable. Click Open. So let's save all that. We want to save our projects here in the main root folder of the hash source. Fantastic. Save all. Now, of course, if we build this right now, it's going to fail. So there are a couple of things that we should do. So first of all, in the executable, let's go into the options. And we want to make sure that we turn off use classic Borland compiler. We want to use the modern Clang toolchain. Using the Clang toolchain has much better language support, language compatibility, language standards, that kind of thing. So we always want to turn this off. And then in the C++ linker, I'm going to turn on link with a dynamic RTL and link to the Delphi runtime library. Those are both useful options. And then for the library, I'm going to set up something very similar. In C++ compiler, I want to turn off use the classic Borland compiler. In tlib, in C++ linker, I want to make sure that the dynamic RTL is on, the same as the other settings. So the first thing to do is not the executable, because the executable is just a thin wrapper, although it does pull in a few headers and that kind of thing. Let's get the library building first. So first of all, let's build, and we would expect to run into problems. And sure enough, we do. This hash includes strings.h, that isn't found. And if we scroll up here, we can see that the header file here, platform.h, has something set up for Visual Studio, and otherwise it does everything that's not Visual Studio. And that's the section that we're in. And sure enough, we are not Visual Studio, but we do want to have something set up to be a bit more standards compatible than whatever this is. So instead of strings.h, for example, we want to just include string. So let's set up a hash ifdef codegear C. So we have two branches if we are using C++ Builder here, otherwise if we're not. So we can put the stuff that doesn't work in the if you're not using C++ Builder branch. And let's indent that, because although this header doesn't follow that convention, I quite like being able to see the structure of macros like this. And I'm also going to set up hash include string. Now you notice that I moved this line. That's because I've done this before and I happen to know it's going to cause an error, but let me just leave it there so that we can actually see the error. So let's build. It's looking pretty good. And here we have another problem. So here again we have a macro for if we're using Visual C++ or if we're using anything else. And this is all to do with Windows, basically. You can see here that if it's using Visual C++, it's assuming that it is Windows, includes windows.h, and it has this setAffinity method that uses methods that are a part of the Windows API. And everything else assumes some non-Windows platform. So what we want to do is we actually want to go into this branch, the Visual C++ branch, because it's not Visual C++, it's Windows. It's just been written using the assumption that Visual C++ is the only thing. So let's change this to go if defined codegear C. And so that means for both Visual C and C++ Builder, that will work. So the macro there, defined codegear C, that's not ideal because we haven't been codegear for some time, so hopefully sometime soon we will have a different macro defined, maybe something like C++ Builder. So that's appeared to compile. Fantastic. We didn't actually have to do very much. And you can see because we're using Clang, we have a huge advantage already. We are standards compliant. All we really have to do is go through and check for Visual C++ versus other and decide whether it's really Windows or other, or whether it's really sort of catering to some sort of Visual C++ quirk. And we have both of these in these examples. So here it's not really Visual C++, it's Windows, and here it really is a decision between Visual C++ and set up for other compilers and other runtime libraries. So this is an example of the two different types, the two different categories of problems that you will look for and have to address. So far so good, and this appeared to link, which is fantastic. So let's come back to the executable, and we want to add that library. So let's go here and add a static library, smhash@support.lib. Now notice here when win32 debug, and of course you don't always want to add the debug one. Let's build, but that will do for the time being. So you can see here we have a problem in main.cpp use of undeclared identifier str case comp. Now we happen to have seen that already. That was down here, str case comp. So what we're going to do is we are going to set this up again for codegear versus other. So this one here is wrong, and we're going to put that in the other. We are just going to write hash define str icomp. So I misspelled that, str icomp to str icomp. So with or without the underscore. And this is just a quirk of the different runtime libraries and headers and so forth that comes with different compilers. So you can Google str icomp and underscore str icomp if you want, and it'll tell you about the different compilers and that kind of thing that they come with. So compile again, and we get more errors. Can't link. So we're making progress, but we're not there yet. So you can see here we have an unresolved external murmurhash3 underscore x66 underscore 128, and a similar one x64 128, and another one pmurhash32 test. So let's just start with the first. And this is referenced from main, but it's actually going to be living in smhash support. Let's go have a look at that, we can search for that symbol. Where is it? And so we want to find murmurhash 3 underscore, and we'll look for that, and surprise, it's in murmurhash3.cpp, and there's the one that we're looking for. And we also want to have a look at the header. So let's open that. When you have a file name in your cursor, you can just press Ctrl-Enter and it will open. That's a very, very nice tip. So we have a problem, unresolved external murmurhash3 sx6 128. That's this one here. And it is a const void pointer, yep. An int, yep. Unsigned int, well here we have uint32t, so we should double check that. And a void pointer. Okay, so far so good. And let's go back to the C++ file and search for that. So we have a const void pointer, a constant. Well, that's different because we had just a plain int, not a constant. So that would be why I can't find it. uint32t and a void pointer. And again, we just want to double check what this is. So let's go back to murmurhash3 and we can see that uint32t is a unsigned int. Okay, so far so good. So let's start off by seeing here this is a const int, and of course we had just a plain int here. So we can fix this in a number of ways. All these prototypes should probably be the same, but so let's just go through and make that a constant. Let's see if that now compiles and see if that links. Now at this point we're going to be swapping between the two projects quite a bit because we want to build the library file, and we can only check it by linking the executable. So if you right click here, go into dependencies, and we can add the support library as a dependency. That means that when I make this one, it will first make the dependency, the other library. So that means we have both building, but only actually have to explicitly build one particular project because it's aware of what that project depends on. It's a very, very useful feature. And you can see here that we're linking and there are still errors, but we have one fewer error, so we're making progress. Well, this one hopefully is very similar because it is just another very similar method. We just solved x86, now we have x64. So let's have a look at that symbol. Then we have void pointer, int, uint32t, and void pointer. So let's go back to the C++ file, find that, and looks like we have the same problem. It is a const int here. So let's just make that a const int. And now let's compile. Now notice I'm compiling smhasher. And that is still not linking. Just want to double check. I may need to build instead of make. Yeah, so here we go, is building the library file. It didn't pull up that the header changed because the header isn't part of the library, so it didn't realize that it actually needed to redo that as part of a make. However, that still doesn't work. So why is that? I was looking for a const void pointer, const int, unsigned int, and a void pointer out. And what do we have? We have a const void pointer. Just double check that that's what we have. Yep. Const int, const uint32, and a void pointer out. Okay, and we have another difference in const. So if I go back here, this is just uint32 seed, whereas here it is a const uint32 seed. So just to make this the method here compatible with the prototype, we'll just change that. Now let's compile. And we're down to just one linking error. Well, that's fantastic. Okay, so let's look at solving this unresolved external. It's referenced from main.obj, which will be the main.cpp file. So let's see if we can find where that comes from. So I'm going to search for pmohash32 test, which I happened to search for before. Now notice that I'm not searching for the underscore in front of it. The reason for that is that an underscore may indicate that the mangling is different. Maybe it's you're being mangled some other way. You'll see in a second where that comes from. That's just a hint. So let me search for that. And I find it's in main.cpp, and I'm sure it's using it, but it didn't find anything else. Well, that's very odd, because it should find that method somewhere where it's declared. Why can't it find it? So let's have a look at what this is including. Let's have a look in the support lib. If I just expand that, maybe there's something called pmohash.cpp. I can't see it. Again, that's very strange. And notice here I have pmohash.h. So let's open that. That's probably why when searching for it you can't find it, because this is the header file for something that's not added to the library. But again, that's strange, because we added all the C++ files to the library, so what's going on? pmohash32 test. Okay, so this definitely declares that method, and that's why it's an unresolved external, because it thinks it should exist. And here you can see that we are wrapping these methods here as extern C, and that's why the name mangling changes. So we're now in the position that we know that the method is declared, but we don't know why it's not in our library. Why is that? And there's a header file that appears to be for something else. Perhaps it's a C file instead of a C++ file, and we were only adding C++ files. So let's go back to the support library and click Add. And if we go into source, what we were adding before were all these C++ files. But maybe there are some C files as well. And look, there we go, we have pmohash.c. So we missed that the first time round because our filter here was set to only CPP, not C. So let's open and add that. Now, hopefully, if we build, it builds and links. Look at that. So let's run and see what happens. So I'm just going to run without debugging because I happen to know what happens. And here we go. The app is running, and it is now running a number of tests on itself to verify that the hashing is correct. And this is worth doing as well. You know, it is great to check that you get the results you expect when pulling in code that's built for a different compiler. But I happen to know that all these tests pass, so I'm just going to close that now. So that was an example of taking an incompatible C++ library, or rather C++ library that wasn't written to be aware of C++ Builder, and building it with cbuilder. We chose the example of murmurhash3, which is a very useful library, but small enough that it could take a few minutes and demonstrate it live. And like many things, it was set up for Visual C++ and CMake. So what did we do? Well, first of all, we recognized it was a CMake project, so we opened CMake lists and we recreated the same project structure. And then we set up the projects to use Clang and set a few other useful options. Then we basically just started building and found errors and fixed them. And most of the errors were just to do with some macros that were defined. So there were two general cases there. The macros here were set up checking for Visual C++ versus other things, but that was slightly misleading because there are actually two cases. There is the assumption of Visual C++ versus other compilers, because Visual C++ has some quirks and things like that in its own headers and runtime library. And then there's the assumption that Visual C++ really means Windows. And we saw examples of both, and we fixed both. Then after that, we just had to go through a bit of rote work, just build, try to figure out an error, see what's going on, fix the problems. Didn't take very long, pretty straightforward. A lot of that is quite minimal work because the Clang compilers are compliant. They are standards compliant and very, very useful. So when you're using those, you shouldn't really expect very much trouble at all. And within a few minutes, we successfully had murmurhash3 for C++ Builder. And that means that you can use it from an existing C++ Builder project, or if you're using Delphi, you can, if you have Rad Studio, add C++ to your project. And so you could also make use of the C++ code for murmurhash3 from Delphi if you want. So we saw two things today about doing more with C++. The first was a very quick coverage, because we've covered this before in more detail, about how to add C++ to a Delphi app. So that means if you are a Delphi programmer and you want to do more, you can do more with C++. And if you go to our GitHub repository, it's github.com/Embarcadero, go to the Code Rage 2016 folder and look for the presentation with my name and mixing Delphi and C++. And that links to a blog, and it has example source code which you can just download and test, and it shows all the techniques. But the main thing about doing more with C++ is that you might want to do more than is necessarily always easy with C++ Builder, because there's a lot of C++ code out there that isn't written to be aware of C++ Builder. and you might think that that causes a bit of an obstacle. And that obstacle is true, it does exist. We are working on reducing it. CMake support, for example, is on our roadmap. But when you see an example of how to go through something like this, it's actually surprisingly easy to pull in many of these libraries and use them from C++ Builder. And so that means if you're using C++ in a C++ app or in a Delphi app, and you want to mix Delphi and C++ as in the first link, you can do that. And so you can take advantage of the fantastic third-party C++ ecosystem out there and use it in C++ Builder. So now on to a Q&A.
Great, thank you, David. And I'm just going to pull up that last page here. So we've got the link for that GitHub repository back and available. If you do want to contact David afterwards, then you can go ahead and just use david.millington@embarcadero.com if there's anything directly you want to email him through. So we've had a few questions coming through here, a few people saying really nice to see a really simple example just showing how to connect up and use third-party libraries very easily, and that was all good. A couple of kind of slight in-depth questions going back and forward. There's a question here from Neil. Is there any kind of speed difference between using C++ and Delphi?
There probably is, yes. The reason is that even on Windows, C++ Builder with the Clang compilers has a different code gen backend. It uses LVM. And so you may find that in many cases the code is faster. And I think we actually had a short talk about that in Code Reg last year as well.
Okay.
So yeah, obviously C++ is slower to compile. That's the nature of the language. But yeah, the code you get out will be faster. Okay. And for what it's worth, it's actually something we're working on all the time as well. So in 10.2 Tokyo, we added some extra stuff to another optimization level, for example, to help create faster code, and that's the kind of thing that we're looking at for the future as well.
Okay. The great thing about choosing Delphi or C++, you've got fast native compiled code coming out, and that's something I know from a number of the sessions that we've done in the past, a number of the events that I've been out to actually. It's quite often the bragging rights of the RAD Studio developer, whichever language they're using, talking about the speed and performance they get compared to .NET or anything else like that, because it's compiled languages rather than running through an intermediary. You're probably talking absolute nanoseconds of it compared to the seconds, minutes and hours that can be the difference between using compiled versus interpreted languages and so on in the middle. And certainly there's been quite a few things that I've seen now with different companies switching some of their back end on the web systems as well into C++ and just using more compiled code in different places, because the speed performance and the resource allocation that's required is just so much lower with compiled code. So it's always good to get compiled, which is for sure. So the question here, can you use libraries such as Boost Geometry?
So I haven't actually tested Boost Geometry myself, so I can't give you a definite yes or no answer without having a look. You should be able to though. So I'm actually not sure what version of Boost that's in either. We currently ship Boost 1.55 for the Clang compilers, and it's getting a bit old now, so we're actually looking at upgrading that. But from what I've found, upgrading using a newer version of Boost is definitely straightforward as well. Yeah, so I can't give a direct answer to that without actually having tested it myself, sorry, but in general, yes, definitely should be possible.
Cool. Certainly, you can download certain versions of Boost through the through Getit as well, can't you?
You can, yes. So for the old classic compiler, BCC32, we only ship 1.39, which is very old, but that's simply a matter of language compatibility and that kind of thing. Whereas for the Clang compilers, which are the ones that we were using in the demo today, we ship 1.55. It's a couple of years old. And we certainly want to ship a newer version sometime soon, but it includes pretty much everything that you might want to use.
Okay. Prize to Rob for the obvious question, really. The Linux support for C++. Are there any news on that at all?
It's coming. No news that I can share publicly yet, but
Yeah.
We're working on it.
Okay, great. Now, interesting question here around mobile and memory management. Question saying that Delphi has got Arc enabled, which is there for iOS and Android. I believe Arc is actually already in place for C++ as well on those platforms. But there's a follow-on part of the question is it something that could be achieved with legacy code at all? Is that something we're looking at for the future?
Yes, well, it depends what you mean by legacy code. So first of all, yes, Delphi has Arc, and C++ Builder has Arc for exactly the same platforms that Delphi does. So if you want to use Arc on one of those platforms, you can in C++. Feel free to ask a follow-up question if I don't fully understand what you're asking here. But by legacy C++ code, perhaps you mean a Windows project or something like that, where we don't currently have Arc. I can see the question here on screen says the nature of a project that I'm on at the moment makes it very difficult to know when an object has been finished with. Look, in general, that's a classic programming problem. You create an object and you want to know when it's safe to delete it, when it's used. And that's the problem of lifetime management. Now, C++ itself has some really useful tools for this built in through the use of smart pointers. So smart pointer will manage the lifetime of an object for you. And there are two that I would suggest you look into. There's one called std, so std : so std namespace unique pointer, and one called shared pointer. Unique pointer is ideal when you have a clear owner of an object, and shared pointer is great when you have many things all using it, and it keeps a ref count. It is very similar to Arc in concept. And so with shared pointer, for example, the object will be deleted when the last thing using it goes away, which is exactly the behavior that you want. So I've actually given a couple of talks on smart pointers. So if you look at our YouTube channel, both for the Code Rage 2016 channel and C++ in general, you'll see a couple of talks on using smart pointers, and that's how to address that in C++ in general.
Okay, a really interesting question here from Michael. He's currently using the classic C++ compiler for 32-bit dev, and their aim is to get onto the 64-bit Clang compiler. And he's asking about migration. Would you recommend moving to the 32-bit Clang first and then up to 64-bit, or just jump directly to 64-bit?
It actually doesn't really matter, but Clang 32-bit is very slightly less of a move. So the Clang 32 and 64 compilers have pretty much identical sort of language behavior and that kind of thing. So if any of your C++ code happens to not work in the Clang compilers, it's not completely standards compliant or something, both the 32-bit and 64-bit compilers will give you exactly the same information about that. The difference really would be in the object file formats. So we use OMF on Win32 and ELF for Win64, and OMF is used both for the classic and the new Clang compilers on Win32. And so if you're linking to anything else, you have an import library or something like that, it's just one less thing to work on just while you're converting. So you might find it very slightly easier.
Yeah, I'd probably say go 32-bit first. You've got less variables to worry about, because certainly on the Delphi side, and I'm sure this is probably the same on the C++ side, there's different data types as well. So I know one of the common things that kind of catches people out is the difference between int and native int. So if you've got pointers that are being cast around or anything else like that, just making sure that you're pointing to the right size of data types would be would be a good thing to do. So the move to 32-bit would certainly eliminate any 64-bit issues. And certainly if you're linking, as David says, to any external libraries, then making sure that all that is still working on the 32-bit code before you then move to the 64-bit, because one of the important things when you do move to 64-bit is that you will need to have, for anything that you link to, a 64-bit version of those libraries. So for example, if you had foo.dll that you use, and that's 32-bit today, you will need a 64-bit foo.dll to work in 64-bit. You can't use the existing 32-bit one. So that is something that is, you know, a slightly bigger jump. Now, David, I don't know on the C++ side, certainly it was true on the Delphi side, and originally the Delphi compiler, you could mix in a single function block normal Pascal code and then some kind of machine code into the same block. But was that ever possible in C++, and is that something that's different between 32 and 64-bit?
Well, what I would recommend there is keeping that external. Sometimes people do have assembly written manually, and I would first of all double check if that's still necessary. It might not be, or it might be very old code, something that was optimized many years ago, and it may not still need to be today. But one of the neat things with the Clang compilers is that you can use Clang intrinsics, which is sort of a kind of higher level than assembly, but lower level than C++ system of writing. And you might find that a very useful technique for making your optimized code, and that will work regardless of the bitness, whether it's 32 or 64. And yes, that was a very good point actually as well that you made, Stephen, about converting first to the Win32 Clang compiler, which I can't believe I didn't think of. Yes, when you move to 64-bit, you will have the issues of moving to your 64-bit wide data types like pointers and that kind of thing. And yes, it's definitely worth sort of avoiding those first, just because you have too many variables, as you said.
Okay, so I think Kenneth, I think we might have covered in the last kind of conversation a little bit about your question here, which is about when moving from 30. Actually, no, this is slightly different. When moving a project from Classic to the Clang 32-bit compiler, would most ActiveX controls, etc., still work? I believe they would, because you're not actually changing. In some respects, you're not really kind of changing what you're writing or what you're interfacing. It's just more to do with the compiler that's being used to get you there. So it's still kind of a bit like travelling from here to the train station, but you're either jumping in a car or you're jumping in a bus. Would that be a fair analogy of it, David? Yeah,
that's right. So if you go from the Classic compiler to Clang Win32, ActiveX will still work.
Now, there's another question here. Will it be even more easier to compile CMake projects when Embarcadero offers a direct CMake support?
Yes, it should. So it's not certain exactly what form that will take, but we know that we definitely want to have integration there. There are two aspects to CMake integration. The first is to have CMake recognize our compilers. So currently you can actually already use CMake with the Win32 Clang compiler. I have a blog post about that. But we want it to sort of automatically recognize the Win64 Clang compiler as well. But the second aspect is the IDE or build aspect. Can you open a CMake project and import it into C++ Builder, or use CMake to build or something like that? And we're still examining exactly what we're going to do there. If you use CMake a lot and you have a strong opinion on this, feel free to get in touch. Customer feedback on this kind of stuff is always useful.
Okay. Why is the Classic compiler switched on by default? Question from Aubrey.
Very simply because of the IDE insight. So the Classic compiler and the Clang compiler use different pathways for the IDE tooling. and we want to do a bit more work on that IDE tooling for Clang before we turn it on by default. We probably should have even in 10.2, but we thought we really wanted to work on that a bit more before turning it on.
So from saying that, if you're using the Clang compiler, do you lose anything from the IDE insight at that point when you switch it over, or is it just a compile switch to the project?
No, you don't use anything, and you certainly get IDE insight and all that kind of thing for Clang. We have some underlying work that we want to change in the IDE that will give even better results and much faster. So better and faster than even the classic compiler.
Okay, cool.
That's planned work to arrive sometime soon.
Exciting. Okay, there's TLO just saying that the Clang compilers are slightly slower than the Borland traditional one. Now, I know one of the things that you can enable on the compilers is a multi-threaded approach to them, isn't it? That's part of the Clang compiler options.
You can. Well, you can turn on parallel builds, and that does help a bit. So there are two things here. The first is that the Clang compilers are slightly slower than the classic Borland compiler. That's true, and that's simply because they do a lot more work. There's a lot more complex language that they handle, and a lot more going on under the hood. So they are naturally slightly slower, but you get much better results at the end. The second thing is, and I can see this in the question log as well, some customers report speeds that are too slow for Clang. And what we'd really appreciate there is if you can send through a code sample that happens for. So we had a couple of bug reports about that, and we spent a lot of time in 10.2 examining our Clang toolchain for slow areas. And the Clang in 10.2 is fast. It's really good. If you have code situations that cause some kind of pathological case, and that can happen, please do send that through, because that kind of code snippet will allow us to reproduce exactly what you're seeing. It might be something that's actually only in your code, but of course we would still want to address that if we can. But we would need to see that code and reproduce it ourselves in order to do so.
Okay, I think we're pretty much getting to the end of the questions that have been answered here. Some really interesting questions, everyone. Thank you for those. Dave, is there anything that you want to add before we wrap up here?
Just that you can always contact me at david.millington@embarcadero.com. It's always fantastic to hear from you. So please always feel free to send an email. And I hope the talk today was useful. Just being a live example of a real conversion of code to make it work with C++ Builder, and of course with Delphi as well, which I think is quite neat. I hope that was useful for you.
Yeah, quite a few people just saying thanks a lot, insightful webinar, thank you. So if you want to watch this again, it will be running in a few hours' time. Just go ahead and register for the other section. It will be pretty much the same webinar, and David will be around for some Q&A again. We'll also have the replay up, and will be emailed out to you with your GoToWebinar thank yous, I'm sure, at some point in the near future. So thank you very much to David. Thank you, everyone, for joining, for the questions. Without your questions, it gets pretty dull, me and him just saying hello to each other. So some great questions. Thank you for that. We'll let you get back to your days. Happy coding, everyone, and we'll see you online again soon.
Thank you. See you next time.
Fantastic. Thank you, David, for that great session. Lots of good information on doing more with C++, which is useful for both C++ Builder developers and Delphi developers.
Yes, it is. I think that's one of the great things about Rad Studio, being able to mix both languages in either direction, to add Delphi to C++ or add C++ to Delphi.
That really is. That was one of the things that when Microsoft introduced Visual or .NET, was like, hey, now you can mix languages. You can mix any of these .NET languages. And it's like, we've been mixing languages for years with Delphi and C++ Builder. But anyway. See if I can find the Q&A slide here. That's probably a good one there. Okay. So questions. Oh, why is this still playing? Dagnabbit. Sorry. Apparently I'm challenged today, which is why we started out with no audio or no video. My Mac actually just started to freak out. I got this message on my Mac that said, you're out of application memory. I'm like, what? What swap files are for? Okay. So if there's any questions, go ahead and put in the question panel in GoToWebinar, and we'll get them answered for you here. And so there's a question here, why is the Clang compiler not the default compiler?
Well, that's a good question, and we certainly want to make it the default at some time, probably fairly soon in the future. The real reason just revolves around the IDE Insight, actually. So both the classic compiler and the Clang provider provide IDE Insight, the tooltip insight and parameter lists and that kind of thing. And we just want to tweak the Clang behavior there a bit. Currently it's roughly on par with the classic compiler, but we think we can make it even better than what the classic compiler provides. And when we do that, we will flip the switch, toggle it over to the Clang compiler being the default at the same time.
If you have an existing application that you developed with the classic compiler, is it going to work? Should it mostly work with the Clang compiler, or is there a migration steps you'd expect to go through?
Look, in general, it will work, yes. The Clang compilers are a bit more standards compliant, so sometimes you can have code that will work in the classic compiler and won't work in the Clang compiler. But it's usually pretty straightforward to adjust that. We actually have documentation around all the issues that you might encounter, which I will look up and try and post in the chat. And there's not that much. I mean, there's a set sort of number of things that you might run into and how to solve them. You're probably only really likely to encounter them if you have quite legacy code. They're all quite straightforward to address anyway.
Okay. Actually, it's interesting. The Tokyo compiler, there's a lot of things that were fixed in that were bugs, and it was a little lenient on things with Delphi. And I had a couple people I was working with that's like, hey, this code used to work and now it doesn't work. And we discovered, oh, that code never should have worked in the first place. That was wrong. And then when you fix that, then all of a sudden it worked correctly. So, there are sometimes when you go to a more strict compiler or a compiler that's more compliant with standards that you realize that you wrote some bad code years ago and you're not sure what it actually did because that's really kind of a bizarre bit of code. There's a question here. I take it the Clang compiler is fully compatible with the embedded one in Apple's Xcode?
Well, it should be. I mean, Xcode uses Clang. They might be using a different version of Clang than we are, but in general, it's compatible. Yes. So we're currently based off the Clang 3.3 tree, and we have an upgrade going ahead for upgrading that. And so our 3.3 is completely compatible with Apple's 3.3, for example.
When is that update coming soon to the new version?
It's still in progress, so I can't publicly announce any kind of dates at the moment.
I guess that makes sense.
It's something we recognize as important, and we have planned.
So in addition to supporting the latest version of Clang, are there plans to support CMake?
Yes, there are. So I just typed in the chat as well a link to the differences between the Clang enhanced compilers and the classic compiler, and that page addresses the kind of differences you would see. Sorry, just still talking on that previous question. I've done an upgrade myself for a reasonably large amount of code, hundreds of thousands of lines, from the classic compiler to the Clang-based compiler. It's nothing unusual. So sorry, Jim, what was that question?
Oh, I was going to ask about CMake, if there were plans to support CMake in addition to the latest Clang.
Yes, so that's on our roadmap. There are two issues to do with, two facets to supporting CMake. One is to ensure that it recognizes our compilers. CMake has this kind of, I've forgotten the actual term they use, but they recognize the particular compilers that you have installed that you're using. So right now, for example, you can actually use CMake with the Win32 Clang compiler just fine. I have a blog post about that. But we want to make sure that CMake recognizes all of our compilers. But the second facet is CMake support within the IDE to some extent. Would we import and create a project from a CMake lists.txt? Would we allow to build using CMake from inside the IDE, that kind of thing? We're actually still considering those questions. So if you happen to use CMake and you have a strong opinion on what you'd like to see in terms of our inbuilt support, then feel free to get in touch with us, get in touch with me, and let us know. I don't think I put my email on this site, but it is david.millington@embarcadero.com. And everyone's always welcome to email for any reason, of course, but if you have a particular view about what you'd like to see in CMake integration, then do let us know.
Excellent. This seemed actually pretty straightforward as far as being able to do this, pretty easy. Were there anything you'd do differently if this was like in production, or is this kind of a realistic example, or is this more just a simple example to make it look easy?
I believe it is a realistic example, yes. I mean, the process I chose to find this library was quite literally just open that Stack Overflow question, find the first library that wasn't so enormous it would take a couple of hours. I just wanted something small enough I could demonstrate in a few minutes. And so moment hash was effectively just chosen at random. And I did it once just to see what was involved, and recorded it a second time with a fresh checkout from the repository for this talk. So yes, it's certainly quite realistic. In terms of things we do differently, this was, again, to be short, I was just sort of going through a kind of get things working kind of thing. So there are a couple of things I would do differently. Linking between the exe and the library, for example, you want to make sure that in the debug build you probably link to the debug version of the library, and your release build of the exe links to the release build of the library, and that kind of thing. Another thing is that I changed some of the method prototypes, and the prototypes started out in the header all sort of matching, and the versions in the C++ file had the actual method implementations had slightly different prototypes, which is odd. I wouldn't expect many compilers to actually be happy with that, and I'm slightly surprised that it's like that in the source code. But certainly our version of Clang is strict enough that it does require things to match. I haven't actually opened that up in Visual Studio, for example, to have a look at what it's doing. But you would normally want to think carefully when changing a prototype like that in case it has any side effects. And if the prototypes in the header start out identical, you might investigate, for example, to see whether you can keep them all identical, just as a matter of code style or consistency or something like that. But for the sake of just getting something working, just finding the particular ones that had a problem and fixing those was fine. I tend to think with this kind of thing, a good approach is to get it working first and then review what you did and make it better. So
sure.
If I was dealing with a very large app in an application I wanted to bring in a library, I would be more concerned about demonstrating that the library can actually be used effectively rather than importing it correctly first. And once I had shown that, yeah, sure enough, it's straightforward, I have it working, then I would go ahead and just go through and check everything and make sure it was done properly.
So,
on that note, some of the macros as well. I think I noted in the video afterwards that there was a difference between checking for particular compilers that come with associated RTLs and different functions and different platforms. And the code there in Murmurhash was using a check for Visual Studio or not for the same thing. You're assuming Visual Studio was Windows. I would go ahead and I would be a bit more explicit about that if I actually changed those those hash if defined statements. I might try and actually pull out that logic and make it a bit more obvious.
Actually, when we were dealing with those, it reminded me of when you'd have like an old Delphi library you'd be moving forward. It would always assume that if it wasn't one of these versions, then it was an old version. It's like, no, it could be the new version as well. So I think that there's some of the include files that would fix that as far as version treeing goes. But it was always interesting that everything got assumed to be, if it wasn't what it recognized, then it just assumed it to be something else. There's Marcin just posted here that if you ask on Sierra what Clang version it is, it says Clang 802.0.42. Is that a meaningful...
802. Sorry, let me just run that myself because I happen to be on Sierra. I'm not sure. I wouldn't expect 802. I can see the same thing on screen right now. It says Apple LVM version 8.1.0, Clang 802. Clang is not up to version 8 yet. It's up to version 4, I think, 5 being planned. So they were building off the version 3 tree for ages until they got to 3.9 and then moved to 4, and then instead of doing 4.1, they're going to 5 and so forth. So we're currently based on 3.3. Which is a couple of years old. It's C++ 11 only. We have the upgrade in progress, of course, as I said. But to address the core question, which is it compatible, then yes. They're different versions of Clang, but Clang is compatible with itself. Something that Clang 3.3 can build will be built successfully by a newer version.
Okay.
Sorry, I would have to investigate that version number because it's actually not what I expected to see.
All right. Anyway, I think we're done with questions for now. Thank you, David. This is very, very useful, and we'll put together a blog post that links to a number of those other resources you mentioned as well, as far as like the mixing Delphi and C++. Link directly to that as well.
Sure. Well, thanks everyone for attending and for the questions. I hope you found it useful, and I hope you also found it a good demonstration of just seeing something live, just seeing it sort of converted and seeing that kind of thing in practice. I hope that was interesting.
I found it really interesting.
Oh, that's great.
Great. All right.
And one of the things I think is really nice is that, of course, you can use this not just in C Builder, but you can use it in Delphi as well. So, if you want to use Murmurhash 3 and you want the C++ implementation, you can do that if you have Red Studio, even from a Delphi app. I think that's really cool.
I've had that happen before, where I have a library that's in C, and I'm like, oh, I need this in Delphi. So that's actually something I'm planning to add to my tool belt. Is when I run across something in C and I need it in Delphi, I can just grab it, use it. Okay, great.
Yes, it's certainly a useful thing.
Yep. Thank you so much, David. And thanks to everyone for joining us. And we'll see you all next time.
Thank you. See you all next time.
Bye-bye.